Hello everybody, this is Dr. Christopher White, and in this presentation we're going to continue talking about sedimentary environments and sedimentary rocks. So the next topic we need to address is how do we actually characterise clastic sediments, and this is going to correspond to section 7.4 of your textbook. So the first way that we can characterise a clastic sediment is by looking at the size of the clasts. And in order to do this, we have had to define clasts and split them into different size classifications. So the largest type of clast you can get is a boulder. And a boulder is anything which is larger than 256 millimeters in diameter. Under that we have cobbles, that's between 64 and 256 millimeters in diameter. And then we have gravel, that's between 2 and 64 millimeters. Underneath gravel we have sand, and sand ranges between 1/16 of a millimeter to 2 millimeters in diameter. And you can actually see that sand is split into 3 separate subgroups: coarse, medium and fine. I'm not going to go into the size ranges for those particular groups, but just think of it in terms of sandpaper. So when you have a very coarse sandpaper, you can very easily feel the grains on the sandpaper. That's going to be equivalent to a coarse sand. A fine sand is going to be like a very fine sandpaper, and a medium sand is obviously going to be somewhere in between. Then the two finest class sizes are silt and clay. So silt has a range between 1/16 of a millimeter and 1/256 of a millimeter in diameter, and clay has a size range of less than 1/256 of a millimeter, so it's very small. So in the case of silt and clay, you can't actually see the particles when you're looking at the rocks. The clasts are just too tiny. In the case of boulders, cobbles, gravels and sands, you will be able to visually see the particles. Now, in the case of silt and clay as well, the rocks themselves are often going to have quite a smooth feel to them. They may even feel slightly chalky, because clay and silt rocks can have a slightly powdery feel to them. In contrast, sand-based rocks like sandstones are going to have a feeling something like sandpaper. And obviously classifying gravel, cobble and boulder is quite straightforward because they're easily visible to the naked eye, and so you can quite easily take measurements and classify the sediment based on that. So okay, so that's the size classification out of the way, but are there any other features of the class that we can actually look at to help us classify the rocks? Well, the next feature we can look for is shape, specifically how angular or rounded are the clasts. So if we look at these images here, you can see we have 3 different images, each showing you different degrees of rounding. So over here on the left, we have an image where you can quite clearly see these clasts have lots of sharp corners. These would be referred to as angular clasts. We then, in the top right here, have pictures that show you rocks which are somewhere in between angular and rounded. So as you can see, they have some corners which are angular, but they also have some corners which are rounded. These rocks would often be referred to as partially rounded or sub-rounded. And then finally, the last type of clast shape we have are the well-rounded or rounded clasts. And you can see here these clasts have no sharp edges, and they're rounding towards a perfect sphere or ellipse. And so the question then becomes, well, what causes the clasts to steadily get more angular or more rounded? Well, when your rock initially breaks into clasts, the clasts themselves will very often be angular. However, as the clast gets transported, it has the opportunity to bump into other clasts, and it has the opportunity to rub against the edge of whatever's transporting it, like, for instance, a riverbed. And so this means that over time, as your sediment gets transported, the sharp corners of your clasts get knocked off. And so over time, your clast will become more and more rounded. So when we look at the roundness of the clasts in a sediment, we can use it as a crude guide to say how far has this sediment been transported. If the sediment contains lots of angular clasts, that would suggest the sediment has not been transported a great distance. In contrast, if your sediment contains lots of well-rounded clasts, well, that would suggest your sediment has been transported for quite a large distance, thereby allowing the sharp corners to be knocked off and letting the clast round towards a spherical or elliptical shape. The next features we can look at when classifying a clastic sediment is the size range of the clasts and also the size of the clasts in general. So in terms of the size range, that's simply a measure of how many of the different class sizes are present in our sediment. So if we look over here, we have a type of sediment which we refer to as poorly sorted because it has a large range of class sizes. So we can see that this particular sample contains clasts which are in excess of 256 millimeters, so they're going to be boulders. We also have cobbles, we have some gravel, we have lots of sand, and then also in this dustier matrix we're also going to have silt and clay. So we have a very broad range of class sizes going from boulder at one end to clay at the other end. So this is a poorly sorted rock because it contains all of those different class sizes within the sediment. Now, as we move to this picture in the top right, you will see that the number of the range of class sizes has decreased. So we no longer have the boulders, we no longer have the cobbles. What we have now is gravel, sand, and we'll probably also have some silt and clay mixed in there as well. So you can see that the size range has reduced, but it's still quite broad. We still have 4 different ranges of class sizes. So we still have gravel, sand, silt and clay. So it's not really a perfect sorting yet. As we progress further, we then move into well-sorted sediments. A well-sorted sediment will typically consist of clasts which are all the same size. So this means you would have a rock that consisted of nothing but gravel, consisted of nothing but sand, consisted of nothing but silt, clay, boulders, whatever. Typically it will just be one class size, and sometimes your rock can actually be so well sorted that it will actually just consist of one of the subgroups. So for instance, your sediment, should I say, will consist of just coarse sand, or just medium sand, or just fine sand. So the question becomes, well, what's causing this change in the degree of sorting? And once again, it tends to come down to how long has your sediment been transported for. Typically, the longer your sediment gets transported for, the better the sorting becomes. So why is that? Well, once again, it's all to do with clasts bumping into each other and bumping into other stuff. So as this sediment gets transported, the clasts are obviously going to hit each other. And this means the big clasts are slowly going to get broken down by all of these impacts. And the longer the sediment gets transported for, the more impacts there will be, and so the more broken down those pieces of rock will become. And so steadily over time, the boulders get broken down, the cobbles get broken down, the gravel gets broken down. So that means the size range of your class is steadily getting smaller and smaller and smaller the longer the sediment is getting transported for. So typically, the better sorted your sediment is, very often the longer it's been transported for. Now, the other factor we can look at is the size of the class. Once again, you will notice that we have a change in size. Our poorly sorted sediment over here obviously has quite a large range of sizes, whereas our well-sorted sediment over here has a smaller range of sizes. And once again, as I just mentioned, that's all to do with the length of transport. The longer the transport, the more opportunity you have for bigger clasts to break up to form smaller clasts. So when we look at a clastic sediment, we will look at the shape of the clasts, we will look at the size of the clasts, and we will look at how well sorted the clastic sediment is. And those are all indicators which will give a geologist some idea about how long the sediment has been transported for, which is always something which is very important to know. So in terms of what we were just discussing, typically the further the source of the sediment is from the location where it's been deposited, the rounder and smaller and better sorted the sediment will be. And we just mentioned that, and it's not really a particularly complex idea. Now, there are other factors though that will affect exactly how quickly these changes in size, shape and sorting occur. So the first factor is the steepness of the slope. The second factor is the strength of the current, and the third factor is the agent which is actually doing the transporting. So in terms of steepness of slope and the strength of the current, those two are kind of intimately related to each other. Typically, the steeper the gradient, so the steeper the slope, the stronger your flow will be. So think of a river going down a very, very steep slope. It's going to be moving very, very quickly. This means the water is going to be very energetic. That means the clasts which are being transported by this water are going to be in constant motion, which means they're going to constantly be banging into each other. And so this means the more times they bang into each other, the faster they will round. So in these very fast flowing waters, they'll bang into each other very, very often. And so this will mean they will round off quite quickly. And of course, the strength of the current is a direct reflection of the gradient. The steeper the slope, the faster the medium will move, and therefore the more energetic the flow will be. Now, in terms of the transporting medium, whether it's water, wind or ice, this is also going to have an effect on how quickly your sediment rounds. So in the case of the wind, well, it's not a particularly energetic transporting medium. And so this means that sediments transported by the wind will often take longer to round. And that's simply because when the clasts bang into each other, the force of the impact is just going to be lower. In the case of water or ice, well, those are far more energetic systems, and so this means that when the clasts bump into each other, or when the clasts grind against, let's say something like the edge of your river channel, that means they are going to round off faster. So in terms of the size, shape and sorting, it's a reflection of how long has the sediment been transported for, how energetic was the transporting medium, and how strong was the transporting medium. All right, thank you for watching everybody, and have a good day.